All aqueous solutions that are acidic are measured in pH, potential of hydrogen. They're measured on a scale that goes from 0 all the way to 14. The scale looks like this. Anything from 0 to below 7 is acidic. Then anything ranging from above 7 to 14 is basic. Anything with a pH of 7 is neutral. One thing to note is that the pH scale is tenfold. So if we have one solution with a pH of 4 and another solution with a pH of 6, solution 4 is 100 times more acidic than solution 2.
What defines the pH of a solution?
This is an aqueous solution, and this is a hydrogen ion. They're in acids. An acid is a substance that donates hydrogen ions. Now, if we add an acid to this aqueous solution, it'll be acidic because it has a higher concentration of H plus than OH minus. Now this is OH minus. OH minus is in bases. A base is a substance that accepts hydrogen ions. Now if we add the base to this aqueous solution, it'll now be basic because it has a higher concentration of OH minus than H plus.
What happens if we combine a base with an acid?
That's called a neutralization reaction. The fancy definition for that is when an acid and base react to produce water and salt and to neutralize each other. Now let's get into chemical equilibrium and Le Chatelier's principle. Say we have a racetrack with one side being labeled reactants and one side being labeled products. So say there's two cars that start on each side. As the cars on the reactant side move to the product side, the cars from the product side move to the reactant side. At all times, there's two reactant cars and two product cars. Now this defines chemical equilibrium. Chemical equilibrium is when the rate of the forward reaction equals the rate of the reverse reaction. All reactant and product concentrations are constant at equilibrium. In this example, the cars from the product and reactant side are both moving to the opposite side at the same speed. There's also always two product cars and two reactant cars. This means that the reactant and product cars both have a constant concentration. Now, say a gummy bear randomly crashed into the road. The yellow and white car are going to move around it to eventually get back to their normal rate of driving. This idea is defined in Le Chatelier's principle. If stress is placed on a system at equilibrium, the system will proceed in a direction that minimizes the stress. In this example, that's the cars moving around the gummy bear to get back to equilibrium, or their normal rate of driving. Now, how does all this connect to ocean acidification?
Let's start at the core. There are three different chemicals that play a role in the acidity of the ocean: carbonate ions, bicarbonate ions, and carbonic ions. These all help keep the ocean's pH at 8.1. 200 years ago, the ocean's pH was at 8.2, but now it's at 8.1. This is actually a 30% increase in acidity because one full unit of pH is a tenfold difference of H+. In our recent lab, we added vinegar to water. When we added a shell to the solution, the shell dissolved to increase the pH of the solution, which was lowered by the acidity of the vinegar. In summary, the vinegar made the water more acidic like carbon dioxide does to the ocean, and the shell dissolved to make up for the lost carbonate ions.
So you're saying this happens on a larger scale? Carbon dioxide makes the ocean more acidic?
Yes, the ocean takes in 25 to 40% of all carbon dioxide emitted from human activities, like driving. This carbon dioxide dissolves in the ocean water to form carbonic acid. This reaction produces H+, making the water more acidic. This H+ will then react with carbonate ions in the water to produce bicarbonate ions. In the process, the carbonate ions will be removed. Then shells and coral, which are made of calcium carbonate, dissolve to replace the carbonate ions that were lost in the acidification process.
Now this part of the process ties into Le Chatelier's principle. Shells are dissolved to raise the concentration of carbonate ions in the ocean. This is done to keep the formation of carbonate in the ocean at equilibrium, which is exactly what the principle talks about. Acidity is a chemical property relevant to all life. It's measured on the pH scale, takes part in ocean acidification, which also involves chemical equilibrium and Le Chatelier's principle.